Thanks for that great introduction. I think that's sort of covered a lot of my background. I've been at Red Hat as a senior principal engineer for just over a year now, and before that, I've been involved with companies like New Relic. I founded JClarity, so you can probably see that there is an interest in performance and observability that goes back quite a long way. One of the very first things I did when I joined Morgan Stanley a very long time ago now is to work as the performance engineer on the Google IPO. So the sorts of technologies that we're going to talk about today, JFR and some things which are sort of adjacent to it, has been an interest of mine for a lot of years now. As well as my actual career and the places that I've worked, I've tried to do some bits and pieces in the community as well. I'm a Java champion. I don't live in London anymore, but I did for many years, and I helped to organise the London Java community, and even sat on the Java Community Process Executive Committee for 6 years, which is the body that creates all new Java or ratifies all new Java standards. My latest books are Optimizing Java and the second edition of the Well-Grounded Java Developer. Optimizing obviously is a book about performance. So there we go. Okay, that's enough about me. Let's talk about JFR and what is it, why do we need it, and how does it work? There are a bunch of different ways that you can use JFR, and as we'll see, we'll talk to each of these in turn. You know, the ones you're probably most familiar with for people who have used JFR is Mission Control, otherwise known as JMC. This is a tool for a GUI tool for kind of displaying individual JFR files, and we'll talk about Mission Control a bit, and I'll also try to explain why it's not necessarily the most convenient of tools for a lot of what we might want to do with JFR today. But to go right back up to the top and to talk about what is JFR and why do we need it? Well, what is it? It's a profiling tool. That means that it is embedded deeply inside the JVM. It's hotspot only. So if you're using J9 or Azul's VM, then it's not available. It's not a part of the Java standard. It's an implementation, and it works at a very, very deep level inside the VM. So it has access to all kinds of data and all sorts of events that it can generate. And with the way that JFR has been designed, you sort of can be interested in events down to the granular level of single types of events. I think there's about 130 different events that you could monitor for in JFR. And you can actually turn them on or off at an individual event level. Most of the time, though, people use a collection of switches, which is called a profile, to enable them to produce the data that they want. Now, the advantage of this, it's a certain amount of additional complexity, and although you can produce a custom profile, that's quite a lot of effort. But the aim of it is to be able to give that controllability to the developer, so that you can either have only a few events and have very little impact on steady-state performance, or if you want a more detailed view, you can turn up the number of events that you're analyzing and creating in JFR, and that obviously will cost you a bit more performance. So this trade-off is in the hands of the application owner. You can decide, well, I want some events, but I don't want to sacrifice too much performance, or you can go the other way and say, well, I want detailed information, and I'm prepared to pay for it. So that trade-off, that balance, is what we always see in performance applications. That exists with every type of monitoring and observability technology. Is that trade-off. So, as I've said, it's very much hotspot specific. Although there is some interesting work being done by Red Hat and by Oracle to make it work with Graal VM as well. So, what's the history? How did we get here? Where did JFR come from? Well, if I tell you that it nowadays, because it's open source, it's referred to as JDK Flight Recorder. Oracle's technology version of it was called Java Flight Recorder. But let me give you a clue and say, while the acronym has always been JFR, it actually has another name, or its first initial name, was not Java Flight Recorder, but in fact JRocket Flight Recorder. It goes all the way back to BEA Systems and Oracle when they acquired that company in 2008. The first version of the flight recorder technology came along with it. Oracle then released Java 7 and merged JRocket and Hotspot to a certain extent, and added the JFR technology to Hotspot. Skipping forward another bunch of years to 2018, JFR was finally released as fully open source and parted and put into the OpenJDK fully. With Java 14, which of course obviously is not an LTS version, we got the first version of what's called JFR event streaming. JFR, as you may know, works by producing a file, or at least it did up until Java 14. From that point onwards, you can choose. You can either have a file, or you can actually generate a stream of events. And around that time frame, which I guess was 2020, JFR was also actually backported to Java 8. So it now is available even in the builds of OpenJDK 8 that you can get. So that's a very short history of JFR and how we got to this point. What you might notice is that covers 13 years. So JFR is a mature technology. It has been around for a long time, and it has plenty of production and battle testing experience, if you like. So it's really been used extensively. But I think it's not really in 2018, when it becomes fully open source, that it starts to get some wider usage. You see, for the first 10 years of what we're showing on the diagram here, it was actually a proprietary technology. It was only available if you paid for Oracle support. It was the only way that you could get JFR to use in production. So it's this sort of weird combination of it's been around for a long time and is really quite mature, but at the same time, lots of Java developers have never really used it. So, and I think that's a real shame, because it's actually a very powerful and very useful technology. What can we say about it? Well, it's the flexibility, I think, is one of the big things that makes it successful. It does require a little bit of getting to know what events to track and what is available. But I think that once you've done that, you very quickly can become part of a development team's repertoire. Okay, so as I've mentioned, it generates an output file. This is a high-performance binary file of a certain format. I've mentioned profiles already. There are two pre-configured profiles which have got different sets of switches which are turned on within JFR. These are confusingly called default and profile. They're represented as XML files. It's kind of weird they're called default and profile, because then we have the profile, which sounds weird. You can then also control and start JFR in various ways. You can start it with a command line flag. So you can start by passing just some -XX switches. You can start JFR dynamically at runtime with a J command. You can also start it using JMX as well. So there's some quite interesting different ways that you can actually activate JFR. Okay, this sounds great. This is this is the how and the what of what JFR actually is. One thing we haven't touched on, of course, is the question of why. Why do we need this? Well, because cloud native is increasingly our reality. According to data from New Relic from earlier this year, 70% of Java applications are already containerized. And that number is still rising. Now, there's a caveat here, because it does depend upon the individual segment of the market and the maturity, but it is very much the case that we are seeing more and more apps become containerized and move to the cloud. We also have a sort of increasing usage of microservice architectures, and they tend to be more complex. So we need some tools that are going to help us make sense of this. And that really leads us into the topic of what's called observability, which is really the sort of the coming together of things like APM and monitoring, and to deal with more complex cloud native and microservice environments that we're seeing these days. There's a whole bunch more data in the New Relic report. So if you grab a screenshot of that, you can talk to them. You can read the conclusions that they have there. But in a couple of slides, APM is a 15-year-old plus technology. I remember encountering it for the first time around about 2007 at Morgan Stanley, and the world then was very, very different. We sort of had release cycles that were measured in months. Everything was monolithic, and we had our own data centers. And that means that the architectures are not only relatively simple, but they're quite static, because if there are months between releases, operations teams get to understand what the failure modes of their apps are. So we can end up with a situation like this, typical old school 3-tier architecture, and that will have a deployment every few months or so on. Now, modern applications, of course, aren't like that. There are more services and components. There's more complex topology, if you like, and there are new technologies with new behaviors that we have for things like dynamically scaling services and containers and Kubernetes. And there's a typo, I should say function as a service, but I've managed to misspell the word service, which is good. And things like Kafka, of course, as well. So this complexity has some incumbent problems with it. And so what we want to do is we want to start thinking about observability within Java applications, and that there's sometimes some confusion about this, and I'm going to come back to this point, but to give it to you in just a couple of sentences, observability is supposed to be conceptually simple. We instrument systems, gather our data, we send it out of our application and into an external system that can store and analyze it. And what characterizes observability is this idea that once you have the data about your application, you can ask questions about it. You can try out hypotheses. You can do something which looks a little bit like experimental science or data science. And that as you go on looking at the data and figuring out what's happening within your system, you will find that you need to construct and ask and have answered questions that you didn't know that you would have when you started. So it's about doing some analysis in a kind of more iterative way. So the first step to this, of course, is we need data, and we need to somehow take the internal state of the system, represent it in our observability system, and then from that we will be able to do things like diagnose an outage, things like being able to tell whether or not a particular release is good or not. All of those sort of types of things, which are, I guess, more operational or more DevOps in nature. Okay, so that's the sort of the high level theory of what observability is. And I want to see how JFR starts to fit into that and some of the context which goes into it. So we have, well, one of the ways of switching JFR on is by just using a set of flags. So this will be passed to a Java process at startup. So you can just set up a bunch of different options on the flight recording tag. So we've got a dump on exit, which basically says when the process exits, produce the file on disk. We say what the file is going to be, and then we have settings that you don't normally see both of. You have max size and max age, and that is for effectively running JFR in a kind of continuous buffer mode. The alternative is in the second box on the screen where it says duration equals 200 seconds. Now that basically is for a process which is going to start up, and we're saying activate JFR at the start and run for 200 seconds of recording and then terminate the recording and dump it out. That's okay, but if we want to do sort of long, if you're doing a performance experiment, that may well be the kind of thing that you want. You want to run for a particular period of time and see all of the application startup part. When you're running in production environments, it's actually not as common to do that. because you don't know how long the application process is going to run for. So it would seem silly to only have a fixed duration. So instead, you tend to use the max size or the maxed age flags, and those produce what is effectively a ring buffer. So what that does is it continuously holds, in this example, up to a gig's worth of events, and it stores them in memory, and you can dump that recording out at any time. The difference between the two flags is max age says how much data to keep. Now, 1 day would be a lot of data, so that's probably a little bit high. You might consider keeping a couple of hours. But what that doesn't tell you is how big the data file is. So if you use a strict max age setting, it can be, and there's a lot of activity that could cause a lot of JFR events to be generated, and so then that can blow up the size of your process. And you could even, under extreme circumstances, if your container limits were too low, you could actually blow your process up doing that. So an alternative is to say, okay, I want to keep up to 1 gigabyte's worth of JFR events. That won't exactly tell me how much time that corresponds to, but roughly, more or less, it should stay the same, unless we see a large amount of event generation, in which case, obviously, the more events we generate, the less time a fixed amount of space will represent. So typically, we do that option, and then you can just dump the file out, and you can kind of go back in time. Is the other way to think about it, because if it's a ring buffer, you have all of the events, which new events are overwriting the oldest ones in the buffer. So you get a period of time, and that means you can go back to before an outage and examine what happened. So that can be kind of a useful technique as well. It's still a little bit tricky because you still actually have to control the reading, the recordings, and actually get them off of the box or out of the container, and that can be a little bit problematic. So the other thing which you can do is you can use the J command, JCMD, and this basically enables you to start and stop and control recordings of JFR without needing to have supplied the parameters at start. So you can just control things, and well, we could see that in action. So one of the things that I like to use as a benchmarking tool is this project called Hypothesis. And it comes from Amazon. It's part of the Corretto project. And it basically provides a couple of tools for testing out the memory subsystem. So we can, for example, so this would be a sort of standard command. Well, we don't want to wait a whole 3 minutes, but let's just do 60 seconds. Okay, so that fires up, and in about 60 seconds time it will produce us this file. Now, what we can do, of course, is if I set another one running without the let's just give that a bit more time to play with. Helps if I actually change into the right directory. Right, so that will run sort of pretty happily now, and now I can just type JPS, and you can see that we've got a couple of things running. So we grab the process ID, which is this one, and then So we can just pass in some parameters like that. And that started running. So that's dynamically started. Oh, that one's undocked. Never mind. So now we've got a couple of files that we've created. So I can stop that one running now. And that's, you know, just the basics of how we use jcommand and the flags to start up and run various files. And now you see from the command line we can also do some other things. There's actually a JFR. Let's just check what Java version I'm on. There we go, 17. Good. So there is actually a JFR command here, and I can actually, if you type JFR, it gives you a list of helpful hints. So we can do, for example, JFR print. And let's take some sample events. And that will produce you all of these different pieces of events. And this format is not exactly JSON, but it basically breaks the event down into its component fields here. You can actually get JFR to output in genuine JSON, but that tends to produce quite big files. So yeah, so that's just the basics of the JFR command. There's other things you can do as well. You just do a JFR help. You can figure out what else is assemble, and you can do some quite advanced stuff with this, including breaking apart recordings into files and chunks. Okay, so what else can we say? We've talked a bit about this. We have a JFR as a ring buffer. So let's see mission control. So we've got these files now, and we want some way to work with them. Yes, we have the JFR command line tooling, but it's not as useful as we might like. What about some sort of GUI tool? And in fact, there is a mission control, which is it's based on Eclipse. So when you see it, it feels and looks a bit like the Eclipse IDE. It comes with an official parser which uses OSGI. There are other parsers for JFR files which exist, and it's kind of interesting because there's no real specification for the file format, and it does change from version to version. For example, new event types are added, but also there is sometimes changes to the events as well. So trying to keep up with the file format is a little bit difficult. It was originally bundled with the Oracle JDK, and it's now a separate project licensed under the open license. So that's bring up mission control. So as you can see, you can probably tell the Eclipse heritage there, because this does look a little bit like the Eclipse IDE, but that's okay. So let's open up a file. So here's one I made earlier. And this was from some research that I did and published on Oracle's on Red Hat's developer site recently, about Java application using memory and so forth. So this is if you look carefully at the stack traces, you can see that this, sure enough, this is part of the HyperAlloc benchmark. What have we got here? This is a pretty straightforward summary screen, and it's got like nice toggles that you can turn things on and off with, and you can see that effectively the application is doing this what's sometimes called a double sawtooth, because the little drops correspond to young garbage collections, and the large drops correspond to a full GC. So, and then you can see that we've got the threads here. So in all of our threads, we've sampled a bunch of different times, and you can see that the stack traces for each sample thread are here. So all of the major components of the JVM will have some representation here, whether it's the method profiling, or whether it's the garbage collections, or whatever you like, really. So for the GCs, you can see all of the different sub pauses of the different JVM, different GC events. So we have evacuation pauses, which measure in milliseconds, and then you can see down here that we've got the sum of pauses that we'd expect. So G1 defaults to 200 millis as the maximum time that it will run for, and you can see that in any given window we're getting nowhere near that. We're looking more like 25. Well, that one is 18.9, call it 19 milliseconds in a 2-second window. So all this looks pretty healthy, and this is kind of what you would expect, that the GC is able to keep up with the allocation that's happening. We don't have allocation switched on, so we can't see that, unfortunately. Yeah, the compilation isn't that interesting, because this is really just all about allocating memory and testing out the subsystem of allocation and GC. Okay, so this is mission control. It's pretty useful. You can also start JFR from Flight Recorder, so you can actually connect to a live process. Let me see if I can do that. Okay, so that's running, and now if I click on the JVM browser, you can see I've and so then this starts up a and so this is now running in continuous mode. So we'll just give it a few seconds to actually generate some data. And so what we want to do is we want to dump the last part of the recording. And you see now that we actually have some allocation data as well. We can actually see what's happening. So we've got like the compilations of some of the methods that were actually built. So yeah, so that's live JMC, where you can control and activate JFR recordings, even if the process didn't already start with them. Of course, it only works on the local machine. You need something like a JStatD or a JMX server for it to work across the network. And to be honest, that typically is a bit of a pain to organize. So this mode of JMC typically tends to be used for files. Okay, so let's come back to the slides. So yeah, this is just the event options that we set up. But as well as the files that are generated and the use of a GUI tool, JFR also has a programmatic API. So this enables you to work with JFR files and events It's located in the module jdk.jfr. So notice that once again, this is not a Java style module, so this is implementation dependent. You can use it to do things like parse JFR recording files, and you can read individual events and deal with the data types that come in. So, for example, you might want to do something like this. So here is a very high-level schematic view of how you would handle a JFR file. You start with the recording file class, which you generate from name of, and then you have a while loop over it, and just keep taking more events from the recording file object that you have, and then each event which is non-null you need to deal with in some way by decoding. So the actual real work would be done in the decode event, but this is just a very simple schematic of how we would actually parse a file. Where's the IDE gone? I can probably get rid of mission control at this point. So this is a project called JFR Hacks, and let me show you. So let me zoom the font size a bit. Just as before, you see we have a recording file, and then we have this while loop where we loop over it. But now I have this this concept called a handler registry, and the point of these things is to set up handlers for individual event types, so that then you can register whatever you need in terms of which events you want to deal with, and then we have a simple setup where, as the event comes in, we loop over the registry, and if the handler will accept this event, it returns true, so the filter passes, and then we just for each and accept the event into any handlers that are left. Okay, sounds good. So let's have a look at the handler registry, and this basically takes this type called recorded event handler. And recorded event handler is an interface which is both a consumer and a predicate. So the consumer is what enables the for each part, and the predicate is there to provide the test. So this is a essentially a tag interface. So we have things like we need to get the event name, and you need to supply that method. The general test method is defaulted. So essentially it just checks to see whether the name matches the results of getName. And then you have a shutdown method as well that you need to supply. And a couple of optional methods which deal with any threshold or polling duration. Certain types of event, such as CPU utilization, show up on a polling duration. So you can say, give me a poll on my CPU once a second, or however long. So that's the primary interface, and we've got things like, well, this is a CPU load handler. So this sets up things like the name of the event is jdk.cpu load. We have some different fields here: JVM user, JVM system, and machine total, and we need to get the details. So we just take the incoming event, and this code will only be fired if we have an event of type JDK CPU load. So if we have the fields JVM user, JVM system, and machine total, then we can output those into our file. So the point of this is to take a JFR file recording and to parse it and turn it into some simple CSV files, so that then we can load those into Excel or do some charting with them, or I've got a Python script which manipulates them and stuff as well. So that's the CPU load. Let's have a look at another one. That's object allocation. Let's do that one as well. So this is similar. It has an object allocation in UTLab, and this basically is how we detect allocation rates. Because when a Java thread is created, it's given a private area of Eden, which is called a TLAB. And what happens is, because it's completely private, no other thread can have access into it, which means that the allocation of objects can be very efficient, because you just you know that there is no other thread that is going to be contending for that buffer, so you can just allocate a chunk of memory, and allocation becomes a pointer bump. So that's why it's done. It's really pretty efficient. But then what happens is, when you fill up your TLAB, the thread needs to go back to the JVM and say, hey, can I have another TLAB, please? So that is what is detected by this event. So we can see the allocation of a new TLAB. So that means we can see that the object allocation is about to happen. Of course, if the JVM doesn't have any more TLABs to give out, then that will trigger a garbage collection event. So the TLAB allocation is quite an integral part, an important part of the overall way that the VM allocates memory. Okay, so what else could we say? Oh yeah, so then the other thing that we do is that because these are potentially per allocation per thread, we then also have a class which handles this on a per thread basis. Okay. So related to this is a project called JFR Analytics, which provides a query interface to JFR sources. This is written in a sort of like an SQL dialect, and I noticed that autocorrect has changed the name of my colleague at Red Hat and decided that his surname needed to be corrected to Morning, so I better fix that as well. This runs on top of Apache Calsat, which is sort of an SQL-ish wrapper over the top of any kind of data store which could support it. The source code in the project is there on GitHub, and I can use it to generate these types of graphs here. So I wrote this article back in April for talking about how to run Java in single core containers. This is kind of an interesting topic, because lots of people do run Java in single core containers, and they don't necessarily realize the implications of doing that. One of the takeaways, if you want, from today's talk, is to analyze your container setup and see if you're running in single cores. If you are, then you may well find that it's better not to be. Okay, so let's come back into the IDE. I'll just do a very simple. So this is the JFR analytics in action. So I've got an analysis class here, which is going to take a JFR file and parse it and turn it into CSV files. So this is a similar approach, but I'm showing you how to do it using this this Apache Calsite approach. So we have a class called JFR Schema Factory. We generate a model from the file, and because the JFR format is self-describing, that means that it can derive what the schema should look like by reading the file itself. After that, we just set up a straightforward connection manager, and then we run some SQL against the resulting data source. So this is just plain ordinary JDBC code, but we can use it to collect data from the JFR file. So this basically enables us to pick out things like the young GC, the old GC, the number of parallel and concurrent threads for GC, and then we can use it to pull the data that we're gonna write out. So you can do all sorts of interesting things. You can do like the GC timings, where we get the start time, the heap use, duration, etc. And we can do perfectly normal joins. You need to be a little bit careful with how you quote stuff, but it does actually work. So after having done that, we can then we're collecting all this data into the various things like stop node collections by ID. And then we just output some CSV which has that data in it. So coming back to this, we've only got a couple of slides to go. If you can see a load more of these diagrams in the in the piece, and if you go to my repo on GitHub, you'll find a JFR hacks repo there where I the code that I've demonstrated will be in there. This is all good, but it's still geared towards debugging a single VM and a single file. And that's not really what we want for monitoring and observability. We want a stream of telemetry data. And so what are the solutions? There are 4 different approaches that I know of for handling automated JFR and taking it into an observability context. There is on-demand recordings, which is what we do at Red Hat with our product called Cryostat. There is the creation of a pseudo stream, and that's basically what I wrote at New Relic. Now that works on Java 11 and 8 by taking lots of little short recordings and overlapping them, so that you can then deduplicate and end up with a stream of telemetry data. Datadog do something a bit different. They have a sequence of chunks where they disassemble a JFR recording file and send individual chunks up and then process that in the back end. Finally, there's JFR streaming, but that is Java 17, if you want an LTS, which I assume you do, Java 17 only. So that is still coming, although it's probably the most promising of the 4 approaches. Everything else works fine, but it's really the true streaming approach that I think most people are going to want. So because I work for Red Hat, I have to show you this diagram of OpenShift. And that's really what we want to get to. We want to get to a place where all the Java components here are going to be using observability, probably backed by JFR, to get data out. I'm going to skip that demo because I don't think I've got a lot of time left. JFR continues to evolve, new event types. As an observability source, it ties up nicely with this concept of the project called OpenTelemetry, which is the fastest growing project at the CNCF, the Cloud Native Compute Foundation, and it's really nice. One of the things that we are also starting to look at is profiling, and that is a major area of interest. There's some work being done at Datadog, and myself and a couple of colleagues at Red Hat are also very interested in how do we get execution profiling into the space as well. Java 17 adoption rates after 1 year. I'm sad to say that the adoption of Java 17 in production, according to New Relic data, is around about 5%, which is pretty low. After 12 months, we would have hoped it was more than that. But there we are. So until that adoption rate rises, JFR streaming is going to be a very niche solution to the problem, which is a shame because it actually is probably the best way to do it. You can use JFR streaming. I think the way that lots of people do it is with a Java agent. So effectively, we'll have some code that looks like this. And so this uses a pre-main to attach and then to start up. And this time, instead of a recording file, we have a class called recording stream. And that basically, you effectively attach callbacks to it. So you have a sender class here, which is a callback handler. And then from there, when that event is called, the callback handler will receive the event. You can do some event filtering on that and reduce the number of events that callbacks process. Basically, this is once again this trade-off between how much processing power you want to take for doing your monitoring versus how much you are going to use for the application itself. So you're trading off application throughput again. Okay, so these 3 pillars of observability, I just put this in because it's a way if you're interested in observability and how you might start using it, then this is a good way to stop. Good way to start your journey into observability. And I think I've got about 5 minutes for questions. So my conclusions overall is JFR is underappreciated, but very mature. It provides the best available data that we have in terms of performance and telemetry for the JVM. Historically, it's been overly dependent on file-based recordings, but there is a new streaming API. We need bridging technology to make JFR more usable for monitoring and observability, because we have this absolute gem, but we don't use it widely enough because of the awkwardness of using file-based recordings. There is work being done on this. There are active open source projects to bring together JFR and other observability technologies, notably OpenTelemetry, and that's kind of part of what I do all day. So that's it. Do we have any questions?
No, actually, no questions so far. I wrote in the chat, so yeah, please don't be shy. Type your questions to our speakers. So you still have a couple more minutes to use this chance. While I think once again, Ben, for all your efforts, for your contribution, for joining, for being so kind to offer your career mentoring sessions for those who donate for 300 euros and more. So I'm sure this will allow us to reach our goal, and this will bring our victory closer. So thank you once again. Let me check if no questions. No questions. Please enjoy the rest of the conference as a participant. You should have received your link to be able to do this in your email. And for our participants, we are going to have a short break, and we'll meet you soon at 10 minutes to 3. And we'll continue with our next speaker. Thank you, Ben. Not sure if you still can hear me because
Yes,
I
I
don't
can.
see you.
Thank you so much. Glad I could help, and we'll see you soon.